Okay, we're going to move right along and sort of pick up the pace as we start filling in more gameplay mechanics into our project. So I think the next thing we should do to sort of break up the monotony in our game is add a power-up. So in other words, some kind of game object that you can run over and pick up and, build up a meter of sorts, and then when you want to, spend that meter for some kind of power-up that we'll determine later. So the first thing we'll do to achieve that is add another game object. Let's call it PowerUp. So right-clicking on our hierarchy here, we will call it PowerUp. And it's going to be another sprite-based game object, so might as well add a sprite renderer. Now I'm just going to give it a default position in our scene here. And since we'll be essentially collecting the power-up, we may as well put it on the same sorting layer as the cube, player 1 in other words, and same order in layers, so it doesn't really matter, but let's just do that. And I made another sprite image for this, so I'm going to import that, called Tabers. That's going to be our power-up. I bet most of you probably know who I'm referring to, Bob Tabor. I kind of consider him my mentor in C#, and a lot of you I'm sure as well. But in case you're not familiar with him, this is Bob Tabor, who runs learnvisualstudio.net. And, well, in my mind, this is an homage to him, so we'll be using Tabers as a power-up. So we will set the attributes for that like before, make it point so it doesn't filter, and make it all fuzzy. And apply that, and we'll just drag it over there. Okay, so the first problem we'll need to solve is to, once again, as we did with the sphere controller, is sort of roll our own kind of collision detection, and based on that, destroy this power-up, and then increment the power meter of sorts. So let's create a new script, let's call it PowerUp controller, and attach that to our game object. So we'll attach it to the PowerUp game object as a component and open it up. And what we should do first is, I guess, get a reference to the cube game object so that we can do this collision detection. So for this, we'll go back to the previous way of finding it using the gameObject.find method, as opposed to the other way, which is dragging and dropping directly from the inspector, as this could kind of cause problems. I know this ahead of time, so let's just do it that way. So we'll make a field, game object, call it cube reference, as we did with the sphere controller. And in start, we'll set that reference with the find method from the gameObject class. And now we can simply refer to how we calculate the distance between the objects in the sphere controller and sort of copy that and paste it here. So let's go to sphere controller. And that was where? In the enemy proximity method with distance. And oh, now I realize we never did change this to a local lowercase variable, following our camel casing rule set that we're trying to impose on ourselves to make things a little easier on ourselves while we look at our code and can see at a glance if it's a field or a local variable. So I'm just going to quickly make those changes and save that. So I'm going to just copy all this stuff right here, and we'll plunk it right into our update method for our PowerUp controller. But I want to make this code a bit simpler actually now that we know about constructors a little bit better. So let's rework it with the following minor changes, I suppose. Just take that out. And actually we'll leave the comment here. We'll make a new one. We'll say eat or destroy PowerUp. All right, that's basically what we're doing here. And in the constructor, we can just pass right in the details as before. That subtracts the transform position of this object from the cube to kind of do this collision detection. So we can just do it this way. And I'm sort of splitting it up on 2 lines so that it's a little bit easier on the eyes. Don't get confused though, this is just an ordinary method and I'm passing in 2 arguments, right? Separated by the comma. Position.y, take away, same as above, but for the y coordinate. And here we will simply, I'm sorry, didn't fix that. And we'll make it a little more lenient. You know, you don't have to be right over the PowerUp, or you're barely touching it. So we'll just sort of make these all 0.5 rather than 0.1 distance. And here we will say, well, this game object, so the property that references this game object is again game object, right? Comes from the component class that we derive from being a mono behavior, which is a component. So we'll just reference game object. You know, you could say this game object as I often do. Anyways, this time I'm just going to do game object. And let's put a comment that's more relevant to this. So I'll say determines whether or not cube is near the PowerUp, some leniency within 0.5 units. All right. All right, so now for the PowerUp meter, what we can do is we can create a field that simply increments by some, I don't know, preset value that we can determine in the code whenever we pick up the PowerUp in this collision detection. So that should be pretty easy. Let's see what we can do about that. So let's make it a, well, so we can see in the inspector, at least right now, we'll say public int PowerUp meter. And we'll give it a preset value. I'll make a little comment. So we give a bonus 50 to the power meter at startup. All right. And right below here we can increment when we power meter will plus equal, so we'll add to whatever its current value is, 100. So that's how much we'll be giving to the power meter whenever we collide with it. And all right, so let's run that and see how that works. All right, so power meter right now is 0. We'll want to watch that as we start out. All right, it's at 50, right? So we're kind of around the power up and we grab the power up, but this is kind of a problem, isn't it? We lose the power up as soon as we destroy the game object. So the power meter, it increments. Actually, it doesn't increment because it would happen after the object is destroyed. But nevertheless, this is a problem because even if it's allowed to increment, that increment is only, or that PowerUp meter is only available as long as the game object is available. So this is going to be a bit of a problem in our script because we know we want to destroy the PowerUp game object. That much is clear. Otherwise, the game object will just linger around and become an endless PowerUp well, which is not what we want. So maybe what we can do is create another class, another script that handles or manages power-ups, including, building up the meter and other useful stuff, and just leave this PowerUp controller script to handle the basic logic of collision detection, destroying the object, and whatever else is just relevant to each individual PowerUp. So let's do that, but before we actually move on to doing that, why not refactor what we have so far, considering we don't want to clutter up the update method, and chances are we'll be adding more code to this class as we move along. So let's do this. All we want from this method is to determine a binary outcome. Either the PowerUp is eaten or it's not, true or false. So maybe it's easier to read if we simply create a method that returns a bool based on this outcome. So let's write something that would resemble that. Let's make a method called, well, let's make it private because we're not calling it outside of this class. So we'll call it 8PowerUp, and just move all this in here. And we're returning, let's see, how are we going to do this? Right, so let's just take this out temporarily and say if this collision detection pans out, we'll just return true. Else, return false. Right? And now we'll want to put this in a conditional that then destroys the game object, and so on, depending on whether or not this method returns true. So, well, I don't even want that in the update method because I'm kind of funny that way. So I'll just make another method to handle the outcome of this conditional check. And we'll do private void destroy PowerUp. And what do we have before? That, so, but we have to then first check whether or not 8PowerUp return true or false. So do this, 8PowerUp, call it within that if conditional because it'll return a true or false. So this is perfectly legal syntax. And then just plunk that in here. Now up in the update, all we have to do is call that method, which itself calls the 8PowerUp method. So again, a little bit cleaner, a little bit easier to look at when you're first glancing at this after maybe a long break of looking at your code. You'll learn to appreciate this kind of refactoring later on when you come back to looking at your code. Also, come to think of it, we should probably destroy the PowerUp after a period of time has elapsed, regardless of whether or not it has been picked up. So in this destroy method, we can use a counter to do this after a certain amount of time has elapsed, all right? So let's do something like this. All right, how about writing the destroy PowerUp method? We can, well, let's start by putting up a timer. Set it to 1 to start off with. And down here, you can just increment it every time destroy PowerUp is called, because this is going to be called on every frame, right? And we'll make another conditional that says if timer modulo 440 is equivalent to 0. So after every 440 ticks, we'll just automatically destroy this power-up, whether or not we grabbed it or not. We'll say GameObject.destroy GameObject, same as if we grabbed it. And well, let's make this public in the inspector. And so when we run this, we can just take a look at that and make sure that even if we don't grab it, it disappears. We'll worry about the other stuff later where we manage our power-ups. So close to 440 and yep, there it goes. We lose our power-up. So alright, so that's a pretty good start, I think. I mean, we still have a little ways to go before we massage our power-up mechanic into a manageable state. So I think in the next lesson what we'll do is we'll make that manager class to do just that and store a power-up meter and all those other good things. Alright, so good job if you've been following along. Lots of cool stuff coming up in the next lesson. Thanks.